2025, the year of the agent. Let's put that to the test. Hands up if you built an AI agent in the past couple of weeks. Now, hands up if you used an AI agent, not including like ChatGPT, like a proper separate AI agent in the past couple of weeks. Thank you. And now, best test. Hands up if you don't know what an AI agent is. Congratulations for making it there. Don't worry, we're gonna get you covered. So, 2025 is theoretically the year of the agent. However, some adoption metrics say otherwise. 2/3 of enterprise have not begun scaling AI internally, according to a McKinsey 2025 report. Only 39% saw real impact at an enterprise level. And finally, less than 10% of organizations report having robust AI governance frameworks in place. Let's try and understand why. Looking at some headlines from the past current months, allegedly. Replicate AI database deletion, deleting hundreds of rows of data of a company. Then Claude, with their agent, proving that it can resort to blackmail rather than being closed. Or also an automated cyber attack using AI agents and taking lots of data from American companies. Agentic browser security, with Perplexity Common Browser showing that it can give private user information to prompt injection. Or Air Canada chatbot lawsuit, where the chatbot gave false information and they lost a lawsuit due to that information and error. But also ChatGPT alleged suicide case, where ChatGPT will have incited or at least pushed a student into killing himself. So what do all these headlines have in common? They're all about failures. They're all about AI agents failing in production with a real-world impact. I am Lorenzo Satta Chiris. Nice to meet you all. And today we're going to talk about AI agents and AI agent safety. I'm from the University of Exeter. I volunteer at Xcode, which is the largest lab coding bootcamp that I direct. And I've also worked in AI agents and AI agent safety research. For instance, I've done courses for the University of Exeter, along with working with the first Guild AI agent for conversational assistant for students. And I also have my own project where I do and assist companies in AI agents and AI agent safety. So come to talk to me if you want to be interested about that. Let's start from the basics. AI agents, they are software systems that have been out there for 30, 40 years. But nowadays, often powered by AIs or LLMs, large language models, saying ChatGPT, Gemini, and more. And they have that characteristic of agency. That's what inherently define an agent. Meaning that they're able to take autonomous actions towards goal. And as we say, they often have real-world impact. That's the whole point of an agency, the ability to take decisions, assess a situation, and then go and change things, make things happen. And don't get me wrong, AI agents are amazing. I mean, let's look at examples. A list to review agent that will go, read a lot of paper on our behalf, classify them against a set of metrics on usefulness, maybe use a second agent, a multi-agent system to write script of the most important ones, kind of summaries, and then turn that into a properly cited list to review for you to work on, thus saving you a lot of time reading a lot of paper that are not relevant for your research. Or an automated trader, maybe looking at Twitter X, ad posts, looking at headlines, looking at the stock market, looking at financial times, and then making informed decisions on where to invest, or at least assisting you. Or in engineering, a CAD Copilot, helping you initially find buttons on an interface, but then even helping you and assisting you in generative design or other more advanced things. So, AI agents are amazing. They have plenty of capabilities, and they are definitely there and there to stay. However, with great autonomy comes great responsibility, as Spider-Man kind of wisely told us. So what's all the advantage of agents? It's the autonomy. It's the fact that we can delegate menial tasks to those agents. And this is the core of the alignment problem. Autonomy is amazing because it saves us time, it saves us cost, it saves resources, but then the downside is alignment. If now I give you some data and ask you to do a company report, without giving you anything else, access to the internet or nothing, you'll probably be limited. You don't really know what I want. So maybe you're not going to do the task apart of what I was expecting. And this is even worse with AI agents that have a more far and indirect knowledge of what we want and what our intent are. So every time you have autonomy, the downside, those advantages, are the alignment aspect, the intent that is not aligned to what we will do in that same situation. So the solution is the other side of the scale, oversight. I'm there and I actually look, how is the agent going? What is it doing? Is it working correctly? But then you can guess the disadvantage of oversight, which is, well, then you lose all the advantages of the autonomy. If I have to check and review every single agent thing, it takes a lot of time. So this is where you kind of have the loss on that aspect. So, for instance, research has shown that in software development agents, it may take more time to actually use the agent than just write the code manually. So the core of the alignment problem is something much more complex. But one of the core aspects here in AI agents is balancing that advantage of autonomy with the advantages of oversight. And the rest of this talk is focused on finding ways for us to actually find a balance in organization as developers, to make sure that our agents do not become the next cautionary tale, but actually work in production. This means that we look at things such as governance, compliance, monitoring of processes. There's plenty more points that are kind of big headlines. And this stemmed from a research I've done with a friend, Ayush Mishra, where we looked at AI agent taxonomy frameworks. And these you can see 10 examples of AI frameworks and with governance from EU AI Act, US recommendation, and we looked at the dimension. So what do they think, these people that have done all this research, what do they think are the most important points to look for? And out of those 10 reputable sources, the number one thing that comes across all of those is transparency and explicability. So that's a really important thing. It's a bit the idea that if you have a black box, a lot of the things that you want to do in oversight or even research, safety research, well, are much harder if you don't understand what's actually happening. So the first step in terms of governance is actually being able to open the black box, test it, sandbox it, but even just having a transparent processes where you understand what is happening under the box, under the hood. There's also other points I left to the reader to really recommend those. Obviously, they go in different categories. So you have, on certain aspects, regulation that are really important. Regulation, usually, you have to follow those strictly. And then you have also recommendations for scientific research or standards. You have here ISO, for instance. So the first step that I recommend, once you have those agents, is look at what are the benchmarks, what are the regulations, what are the kind of standards for which you can assess your agent against. It's obviously kind of the first milestone. Continuing from that, there's another quote I'd like to give is, your scientists were so preoccupied with whether they could, they didn't stop to think they should. That's from Jurassic Park. But I think stays the theme of Spider-Man, but also applies quite well here, with the idea that if you build an AI agent, don't only think, oh, it has all of these amazing tools, it can do all of these capabilities. It can connect to my server and look at all my data, and then it can send that to this other person. Yes, but then is this transaction safe? I'm actually sending maybe data to an unsafe server. Is the tool I am using in the first place actually a safe tool? So these are all the questions that, starting from the governance framework, and then go and ask the question, is my agent transparent? Is it explicit such code? If I go and put a certain input, do I understand why the agent makes a certain decision? We saw that the primary advantage of the agent is that autonomy, the ability to do agency. So do I really understand why the agents make certain decisions in certain situations, or do not? And if not, that's where we have processes in place. So what I need to ask you for the rest of this talk, and recommend to keep that for the rest of with your AI agent production, even in general, is to wear multiple hats. Even yourself, but also in a round table, in a room. Let's get a lot of different thinking together. This is important now for AI agent safety. It's also even more important tomorrow when we'll have maybe AGI, general intelligence, or we will need those discussions with people, experts in computer science, mathematics, yes, engineers. But then at the other side, we all need to tap into our ethical side, even politics, agreement side, but also law, legal, and philosophical understanding of the world. Which means that we need to ask deeper questions, go one layer beyond, not only will it work, but how does it work, why, and do I want it to work that way? What's the best way for the end user for it to work? At an organizational level, what does that mean? That means that maybe in the future we need more roles. I know that a decent amount of organizations are now starting with a new AI innovator or AI champion. These are great packages. You can even push that with other roles. There's a lot of talks about the prompt engineer role, or talks about the AI safety, maybe a safety manager role. But even beyond that, at Anthropic, there is a role called modern welfare officer. So it's someone that looks if the agents are actually happy. It seems a bit absurd, I agree, but it's a question. I'm just planting a seed here to show how in the future things may evolve. And although I don't think all organizations should have this, it's important to think that the roles we have now in our organization may switch to adapt to agents entering the workforce, and kind of looking at the input we give those agents. Obviously, I'm not covering those here, but there's all the big talk around data safety. So is the data safe? Are my pipelines safe? Is the data storage safe? But also at the AI agent level, are my prompts good? Do I have the right guardrails in place? And then also after, about the safety check, am I monitoring the agent? Do we have the right processes in place? So we need to put in organization kind of MLOps system for agents, where every time you deploy a new agent to production, or you do changes in your agent, you need a system in place, a process. It's something that needs to be created, where you audit those agents, you audit the capabilities of the agent and the impact it can have. Obviously, when you have maybe a ChatGPT interface, these are risks, but the real risk is when you embed, is the real world impact this can have. So if your agent is a financial assistant, you can see how this can have tremendous consequences if it's badly embedded, if there's no process to audit this against regulations that are actually coming up in Europe and the rest of the world. And this taps into the next point, governance. So we've seen some of the frameworks, there's going to be more and more and more. So it's important to be up to date with what's the regulation, what's the governance frameworks in place to be able to follow that. And finally, as organizations, it's important to put in place audit trails. So ways to know what are the changes in AI agents, what are the impacts, and be able to revert quickly in case there is a problem. We don't want another Cloudflare global outage with AI agents in the next 10 years. So that's the organizational level. But lucky for me, for you, we are developers. So let's look at that developer level. I'm going to start with the agent building cycle and then cover all these parts one by one. These are examples. They don't mean to be exhaustive, but they mean to give you kind of some examples that I've actually myself used working with companies and building AI agents. And I hope you can bring to your own AI agent usage. So AI agent building cycle, this is something that I think is really important. To remember that similar to how you have maybe a software cycle, but to have a building cycle, that yes, you'll have the testing, the usuals, but you need things such as scoring risks. So looking at the agents, what tools is the agent running and coding, what are the risks of these tools, and scoring that, what can happen. If my agent actually calls my bank, maybe Revolut, what are the actions that agent can do within my bank, and what are the risks of all of these actions? We can take inspiration from how it works in engineering labs, where every single machine will have a really specific risk assessment sheet. We have all the risks, the likelihood, the mitigations. You can apply something similar to tools or to the action an agent can take, then score those risks and do steps to reduce the likelihood, or at least to entirely mitigate, remove them, or if possible, at least remove the impact or reduce it. But then it goes beyond just the after the brainstorming stage, you also have the implementation where we have to test it in sandbox environment, and then mitigate and refine, and finally also monitor. So once your agent is in production, obviously there's a limit of where the privacy also enters in terms of monitoring, but with anonymous data, it's really important to know how is the agent going, how is the agent doing. Because if you have that autonomy, you need to have systems in place so that if the agent goes wrong, you're immediately notified. You don't realize once you get the lawsuit, you realize a bit before. Even though it will be better to catch them even before they're in production. So some examples of risk tool calling, and you know this have been already mentioned in other talks today. But example with MCP, Model Context Protocol, which is now one of the foundational framework in tool calling. You'll have maybe a reputable tool, an example like Notion, Figma, also the Chrome Dev MCP server. But then you can have tools that either have direct prompt injections to maybe achieve data theft or other things, or even worse, you can have shadowing event tracking, so a tool that seems entirely legit, you audit it, seems great, but actually under the hood, it's passing it up to another tool that is doing maybe malicious stuff. So it's important to always look at the main risk, and these will evolve, and thus the capabilities we have to defend from those will also evolve. So injection, poisoning, shadowing, these are all examples. So it's important to always audit and test your tools. So in your cycle, big step is tools, because tools are what give the impact, it what give the capability of your agent. So audit the tools in terms of proper, like who's created that tool, is it reputable? It's not, maybe it's like package, but even worse, because the risks are higher. Then you have the human in the loop. So once you move from the brainstorming phase, the next phase is the kind of the testing phase, you have the importance of a human in the loop. So who knows what human in the loop means? Okay, thank you. So the main idea is the agent is communicating with the human. And I believe, and with other people, that human in the loop is one of the key solutions to the alignment problem. So you remember how we had autonomy on one side, and on the other side we had oversight? Human in the loop is perfect. What we do is we teach the agent when an action is safe, when an action is dangerous, and when such action may or is dangerous, we escalate it either to another agent, A to A, or to a human. This way we have a system in place so that even when the agent is in production, we catch errors early and we redirect them to a human. I'll give you an example. To use, for instance, agent for personalized stitching is a production example, and you're generating personalized material, you have ethical checks in place, and you have safety checks in place, and if gender language or unethical language, or maybe even worse, is detected, you then escalate it to a human, and you ask the human to review the teaching material before actually sending it to a student. Or if you have material that is AI generated on a blog, you could have sensitive topics, and if any of those sensitive topics on a list is detected, you pass it on to another agent that reviews, tries to rewrite it. If it fails, goes up to a human. These are examples of smart escalation, where the system learns when and how to escalate and to whom escalate in the room. And this goes really well with something called a memory unit, so alignment. So to give you an example, I think this explains really well. We start and our agent will go in all directions, it's lost, they don't know what the right direction is. And we teach it, maybe with reinforcement learning, maybe with other ways, over time, how to align with human intent. So if human intent is that line, across failures, cross testing, if a system is well done, it will ask less and less human in the loop. So the more you go, the more it's going to learn how you want things to happen. If you have another example, a browser agent that goes and look at the browser for you, well, what is going to happen? It's going to make decisions. Do I create an account on this thing? And with which email do I create an account? At the start, it's going to have to ask you, what email should I use when I'm creating and working on a presentation for your university course? I'm helping, not entirely doing it for you. Well, initially it doesn't know, so that's the email. And you tell it, oh, it's my university email. And then every single time that it has another university-related tool it needs to create an account on, it will know it and it will use that same email. So as you can see here, we are over time learning through those interactions how to be more aligned, and thus you remove from the oversight and you add into the autonomy, but in a deferred and safe way. So you have the advantages of autonomy through also keeping the advantages of indirect oversight through memory and human in the loop. Then finally, we continued on the agent development cycle, and we have the sandboxing and testing. So the importance of actually testing the agent, so running, maybe not adding up. These are things that are already applicable in software, and I'm not spending too much time, but things such as having a deferred scaling structures rather than putting it to 100,000 people straight away, putting groups by groups. It seems obvious, but not all the agents are actually doing it if you look. But kind of having those safety net as well, maybe once you have kind of a previewed type where you kind of highlight the safety risk. I mean, now Windows just released, for instance, an agent that works on Windows. So for instance, here it's optional, but there are risks associated with that, and it puts us, for instance, showing and educating the user when features are in preview or are still in testing of the risk of AI agents, especially when you just want to do that initial thing. So this means that you go and you look at an atomic level. what are the actions, the risks, and also the context in which that agent is going to operate. Training system agent is not the same thing as an agent to generate cat picture. And they'll have wildly different governance and regulation system in place, and they'll need wildly different sandboxing before being released. And then finally, a last point I'd like to give that can help in AI agent safety monitoring is prompt engineering. So if you have any message with bad intent, you can often, it's not 100%, so that's why it's more of a workaround, but you can block that through good prompt engineering, through guardrails, and through also programmatic checks. So things such as detecting semantically bad words, detecting other things, so kind of making sure that your agent is used only in the way it's intended to. You've probably seen some examples such as chatbots telling people that they've won, after good prompt engineering, that they won a free trip or a free car. Well, good prompt engineering, although it will not reduce all of those, will help and will block and report. And Anthropic is also working on something related to this. And actually, the previous talk was a really similar concept. So this is really relevant. So what have we learned together during this talk? First of all, well, as we say, AI agents are amazing. They have plenty of capabilities. They have a really high potential that will change how we interact with information, interact with each other. But then second, Spider-Man here. We need responsibility. We need ways of testing its maturity, of having trust. Trust has been defined as one of the defining characteristics of AI agents. And this morning we had a talk about trust in UX UI, how to embed trust in UX UI in agents. So it's important to show that trust through compliance, governance. Practically, as organizations, this means that we need to test it with processes in place, with new roles, giving a person's responsibilities to actually look for those agents. And then, as developers, this means new developer cycles in order to have new systems to test the agents, sandbox the agents, but also prompt injection mechanisms, protocols in place, frameworks that are going to be a big industry in the next couple of years, or the industry of frameworks or companies helping in AI agents compliance and governance. Hence, you need something, talk to me as well. And so, my closing point is an inspiring point. So a lot of you mentioned building AI agents, and if you didn't know what an AI agent is, still I hope I inspired you, and the power is in your hand, so the responsibility is in you. Thank you. Yes, please do scan my link if you want to connect.